my name is Janelle Bentahado.
Hey, I'm Adrian Almanis.
I'm Young Nakamura.
And today we're going to be doing a demonstration on our ME106 project. So during our video, we're going to be going over our problem overview, the project design, a demonstration, each member contributions, as well as what we learned.
Do you love rice but hate washing it by hand? Aren't you tired of how messy it gets? You could be cooking other things while you're doing this instead. Well, thanks to our newest product, you can! Welcome our automatic rice washer. Clean, fluffy rice at the click of a button. So easy. Saves so much time. Look at that. Enjoyable. Why clean rice? Well, sushi chefs have figured out how to make the best rice, and it includes washing it over and over and over again so you get all the starch out. Leads to fluffier and healthier and clean rice. As you can see here, our product does this instantaneously. Look how dirty the water is at the end. Why wait? Order now. Call our toll-free number to get more information.
So now I'll be demonstrating how our machine actually works. I'd like to direct your attention to the user interface. And we have several inputs. We have the start button, we have a reset button, and we also have this potentiometer, this knob right here, that lets you select just how clean you want your water to be, ranging from 50% to 80%. You just turn this knob and it'll light these LEDs to show you which selection you want. Let's just choose 60 right now. And add in rice. Add in the water. When you pour the water, you want the water to be high enough so that it would cover this sensor right here. Let's go ahead and press this initiation button just right here. Now when we have the go button on, you can see that the motor is turning this switch right here and then it's cleaning rice. In the meantime, the sensor is also taking in information as to how clean the water is and sending it to this display right here. As you can see, the numbers are fluctuating. Now that the motor has stopped, we programmed our machine so that the drain at the bottom of the bowl would turn on, and all that water from the bowl will be directed through this tube right here into a container. And now that our machine has turned off, you can just take the rice out like this. And that is just about it.
So I did the systems integration and the UI on this project, and we'll go discuss that real quick right here. As you can see on the bottom of this is all the electronics associated to this, and the main feather board would be this one right here. One of the biggest limitations using the feather was that the limited amount of pins. So we actually had to use two, which wasn't ideal, but it is possible. Feathers can talk to each other by sending digital or analog signals, and they're just able to read it from pins just as if they were another sort of input. So the master feather is feather 1. The master feather also controls a solenoid, which will be discussed later. And if you come over here, as you can see in this part right here is the UI. This is where the user can select from the water clarity, 50%, 60, 70, 80, how clear they want the water to be, before pressing go and starting the wash cycle. This here is an emergency stop you can also press, and then right here is the water clarity in real time, so the user knows there's progress with the water washing. Taking off this faceplate, you can see all the wiring that's gone in between that, from a mix of potentiometers, LEDs, and also a display, which will be discussed more in depth later by one of my group partners. So the biggest overarching system design part of this is we needed an actuator, and we also needed a sensor. So the motor right here washes the rice, but the main thing is the sensor, which is a turbidity sensor. This sensor checks the clarity of the water of the rice, sends it to those feathers, and the feathers will calculate whether or not the water has reached a clear enough state. So now from here, I'll go on to discuss the code. So I'm going to be talking about my section, which is the systems level integration and also the UI of the software. A big bulk of the software comes from the user interface section because that's where the user tells the machine basically what to do. It's not a set path, so the user has to choose what they want to do. So starting up right here, you can see where I import all the libraries. I direct all the pins and their naming conventions and set all the variables and the timings. As you can see, starting here, state 0 is the startup sequence where we check the functionality of all the LEDs. After that section is done, we add +1 to the state. Going to state 1 allows the user to choose how clear they want the water to be. And that's taken in with the potentiometer input. A calculation is done down here, and the value is saved as a target for the clarity of the water to be met based on the turbidity sensor on the actual machine. As we go into state 2 is a wash state. It's a flashing green. This is where the motor also tells the motor to spin for 20 seconds, washing the rice thoroughly. And then at the end of that cycle, it tests whether or not it fails by reading the turbidity sensor and comparing it to the user input. From there, you can decide whether or not the target was met. State 3 right here is where the target is not met. State 4 is where the target is met. Both states, at the end of them, will drain the water, and this will be an opportunity for the user to take the rice out, to either put in more water if it fails, or take out the rice and put it right into the rice cooker. Within each state, there's also an emergency stop that allows you to restart the process in case anything happens in an emergency. And as you can see, you go through this, the value of state machines are clearly seen. So the hardest part of this whole process was just integrating all the systems together. Young, Janelle, and I had all individual systems. Thankfully, we all tested our individual systems by themselves before we put them all together. And that really cut down the amount of troubleshooting. So that was the hardest part of the project, and thankfully, we were able to get through it with a nice machine. Go.
So the aesthetics of our project was a group discussion and effort. So as you can see, we went for an all-white design, and this was kind of to keep up with current trends of very minimal, solid-colored looking designs. So as you can see here, our board here is wood, made out of wood, and it was spray painted white. And we had to be resourceful with this. We were able to find scrap wood from the engineering courtyard that we later sanded to make cleaner and smoother and make the spray painting process easier. We put some cushions under the legs here to make sure that when you place it down on your countertop, it doesn't create any damage to your counter. So over here, you can see that there's a hole that we drilled so that all the wires from the user interface on top could flow into and onto the breadboard.
Most people don't. They just want you in and out.
You can see that all our wires are connected to our feathers here, and we taped all our wires together so that anyone can easily see where these wires flow to and which specific components they go to. Up top here, you can see that we created labels so that the user can see easily which subsystems are incorporated and that they can see what we use to create the project. And then now we can flip it over so that we can further explore the design and the motor. So moving on to the front-facing part of the project, we have 3D printed components. We have 3D printed housing to cover the components of our project for a more clean appearance. So if we remove these parts of the project, you can see underneath that we have all our wires hidden. And so we have this here both to protect it from any splashback that may occur from the water, but also just to improve the general aesthetics of the project. If you come over here, you can also see that we created a mount for the motor so that it stays in place and so that it stays mostly hidden from the eye. And over here, you can see that we've designed a faceplate for our user interface that labels all of our buttons. It labels what this display shows, and it also labels our options. And so we also put this here so that we can cover the user interface underneath. On the side of this, you can also see that we have a bracket here to angle the user interface so that it's easier to use. So moving on to the motor, we used a 12-volt DC motor that we bought online. And this motor is used to drive the whisk that rinses the rice with the water. We 3D printed a piece here to connect the whisk to the motor so that it can rotate around generally most of the diameter of the bowl. Right now, I'm going to take a quick moment to go over the program that controls the motor. So in this program here, you can see that we have imported the Adafruit motor kit, which is a set of libraries that Adafruit provides. In this library is the motor kit class. You control the speed of the motor by setting the throttle to either 0, 0.5, or 1, which controls the speed. The hardest part of our project was actually figuring out how to get the motor to run. For me personally, I believe the hardest lab of the semester was the printer carriage lab, so it was hard to take the knowledge that I had from that lab and applying it to this project. So to get around this, after doing research, I found that Adafruit actually provided its own attachment for the feather. So this made programming the motor a lot more easy.
Go.
Hello, so I will be in charge of explaining the draining system for our machine. First of all, I'd like to point out that at the bottom of the bowl, we have this elbow right here that is connected directly to our valve. And this valve is gonna take the water that's drained from the bowl through this adapter and eventually be redirected into a tube, which would be right about here. For our valve, the way we wanted our valve to work is that we wanted it to turn on and off so that the valve would either be open or closed. This is done by connecting the valve through these two wires right here, and they're connected through this feather right here, feather 1. And the way that this works is that this valve is actually powered by a 12-volt power source, and this power source is literally just directly connected to the valve, which is right around here. And then in parallel to the valve, we have a kickback diode, and this is essentially to make sure that the valve doesn't overheat our feather right here, or potentially damage the motor itself inside the solenoid. And as you move down further into the circuit, you can see that this diode and the valve is connected to this component right here, which is a transistor. And this makes sure that we can switch the valve on and off more easily, and to prevent the motor from overheating our feather. And the way that we operate our valve is through the feather, obviously. And the way we do that is that we connect one pin of the transistor into this resistor right here. And this resistor also is in place because we want to make sure that the feather doesn't be damaged by the valve in itself, especially with the 12-volt power source. So now that we have the explanation of the valve out of the way, I want to get into the LED segment display that was also part of our user interface. For our 7-segment display, we wanted to make sure that for our LED display, the numbers, it would switch between numbers, and that would require multiple LEDs turning on and off at the same time. And for this, we wanted to operate the changing of the numbers by using the feather, obviously. And this is done by feather 2 right here. We have the feather connected to a chip that's in between the LED display wiring. And this is done so we can make it easier, especially in the programming process, which I will get into later. This makes it easier for us to locate which numbers we can display on screen, and these numbers are determined by whatever pins we want to turn on and off. So now that we have our machine upright, I can talk more into detail about the initial stage of our draining system. And one thing I'd like to point out with our draining system, what makes it unique in a sense, is that for our system, we actually incorporated the idea of having design differences in our bowls to make sure that our draining system could be as efficient as possible. And this is done by having actually 2 bowls. just layered on top of each other, with one being a slotted bowl, as you can see right over here, and right underneath it there's a solid bowl with no slits on the side. And this makes sure that the process of removing the rice from the water can be as efficient as possible, because it scoops the rice all at once at the same time. So you wouldn't need to scoop out any grains that you might have left behind, because all of it would be inside the slotted bowl, and all the water would be separated from the rice and stay inside the solid bowl right here. And now that we covered the initial stage of our draining system, I'd also like to point out where our LED comes into play. As I previously described, we wanted to operate our LED display by using the feather. The LED display is right here, and this display is working in correspondence to the user interface. Hi, so I will be discussing the LED display portion for our coding. As you can see on screen, we have two lists. We have pins for our left digit and pins for our right digit. And as you can see, these pins are then called through these locations right here. And we wanted to call these pins through binary just to make coding more easier. Each digit for our display is defined by these values right here, which define digits 0 through 9. These digits are then called towards these two functions right here that we decided to call left digit direct and right digit direct, and these just change the values for each of those displays. The display is then changed by seeing, as you can see, this part of the code right here. By taking an input value, we'll just call it val, we decided to separate them by the left digit and right digit values, and the 10s is the left digit, 1s is the right digit, and the displays are then shown on the LED. So one thing I found difficult for this project was actually the LED display, just setting it up and troubleshooting, mainly because some parts would be loose, I may have not connected it to ground, and that would just cause some error in the code, when in reality there's really nothing wrong with the setup, it's just that one part was loose. Yeah.